Hi everyone, welcome to Aviksha Avi YouTube channel. Hope you are doing well. In this video, I am start with previous year exam problems on divisibility rule, and for my previous topics, please go through my link which is provided in description box. If my videos are helpful for you, please watch completely without skipping, and please do like, subscribe and click on the bell icon. Okay, now I will start with first problem regarding divisibility rule. The first problem says the question is the smallest value of y in the number 9y8071 so that it is divisible by 11. This question is asked in the year 2015. Okay. For this, what this question says means they given a number 9y8071 so that this number is completely divisible by 11, and now we have to find out the smallest value of y such that this number should divisible by 11. For this, I just recall the divisibility rule of 11. If you want, please go through my previous videos. What that divisibility rule of 11 says means sum of odd place digit difference sum of even place digits, which is equal to 0 or multiple of 11. Just I apply this rule here to find out the value of y. Here they given a number. Given number is 9y8071. Firstly, I do sum of the odd place digits, that is sum of odd place digits. Here the sum of the odd place digits are 9, 8 and 7. So 9 plus 8 plus 7, which is equal to 24. Now I will do sum of the even place digits, which is equal to sum of even place digits y plus 0 plus 1. Here I taken this y, 0 and 1 are the even place digits. If I done the sum y plus 1, okay. Here for the value of y, here we have to choose the value of y from the options. It must satisfy the divisibility rule of 11. Now I will just put y is equal to 2 from option A, that is I just apply option A, y plus 1 which is equal to, I just put y is equal to 2, which is 2 plus 1 which is equal to 3. Now I take difference between sum of odd place digits and sum of even place digits. Now the rule becomes 24 minus 3, which is equal to 21. But what the divisibility rule of 11 says means it must be equal to 0 or multiple of 11. But it is 21. It is not a multiple of 11 as well as it is not equal to 0. So option A is not correct. Now I will go for option B. Y plus 1. What option B is 3. I just replace the value of y is equal to 3. 3 plus 1 which is equal to 4. Now I will take the difference between sum of the odd place digits minus sum of even place digits, that is 24 minus 4 which is equal to 20. This is also not a multiple of 11 as well as it is not equal to 0. So this option is also not correct. Now I will go for option number 3. Y plus 1 which is equal to, the option 3 is 1. So 1 plus 1 which is equal to 2. 24 minus 2 which is equal to 22. This 22 is a multiple of 11. multiple of 11. So it satisfies the condition of divisibility rule of 11. So option C is the correct answer. Okay. Next we move on to second question. Find the least value of y in the given number 97215 by 6 so that it is divisible by 11. They given an options. Okay, here they given a number as 97215 by 6 which is exactly divisible by 11. So here we have to apply the divisibility rule of 11 which says that sum of the even place digits difference sum of the odd place digits which is equal to 0 or multiple of 11. I just apply that rule here also. Here the sum of the I taken the number 97215 by 6. Here sum of the odd place digits are 9, 2, 5 and 6 and 7, 1, y or the even place digits. Now I just consider the sum of the odd place digits, that is odd place digits equal to 9 plus 2 plus 5 plus 6. I just add up these numbers which is equal to 22. Now I consider the sum of the even place digits. Sum of even place digits equal to 7 plus 1 plus y which is equal to 8 plus y. Now I choose the value of y from the options such that it must satisfy the divisibility rule of 11. So I just taken put y is equal to 1 from the option number A. Then the value becomes sum of the even place digits become 8 plus 1 which is equal to 9. When I take now I just take the difference between sum of the odd place digits and sum of the even place digits. When I take the difference it becomes 22 minus 9 which is equal to 13. This 13 is not a multiple of 11 as well as it is not equal to 0. So option number A is wrong. Now I put y is equal to 2 from the option number B. Y is equal to 2. Then 8 plus 2 which is equal to 10. Now I take the difference from the sum of the odd place digits and sum of the even place digits, that is 22 minus 10 which is equal to 12. This 12 is not a multiple of 11 as well as it is not equal to 0. So this is also wrong option. Similarly, I consider one more option, y is equal to 3. Then 8 plus 3 which is equal to 11. When I take the difference, that is 22 minus 11. The answer is 11. This 11 is a multiple of 11 only. So this is the correct answer. So here the correct option is 3. Okay. Next we move on. Next question. Find the least value of y in the given number 972 by 3 which is divisible by 11, and the given an options as 7, 3, 2, 5. This is also similar to above problem only. Here we have to apply the divisibility rule of 11, that is sum of the odd place digits difference sum of the even place digits. So here I take the sum of the odd place digits, that is 9 plus 9 plus 2 plus 3. These are the sum of the odd place digits, which is equal to 14. Now I will take sum of the even place digits, that is 7 and 7 plus y. 7 plus y, which is equal to 7 plus y only. Now I choose the value of y from the given options. I put option number A, y is equal to 7. Then it becomes 7 plus 7, which is equal to 14. Okay. Now I just apply the divisibility rule. That is, the result must be 0 or multiple of 11. So I just apply the divisibility rule. Sum of the odd place digits minus sum of the even place digits. That is, here the sum of the odd place digits is 14 and sum of the even place digits is 14. So 14 minus 14, which is equal to 0. I already said it must be 0 or multiple of 11, but here we get 0. So here the correct option is 7. Next question is, the value of y for which the 4-digit number 51y3 is divisible by 9 is 2. The options are given here: 2 or 3, 0 or 9, 0 or 3, and 3 or 9. This question is asked in the year 2015. Okay. Now they given a number 51y3, so that this number is completely divisible by 9, and we have to find out the value of y. For this, I just recall the divisibility rule of 9. What the divisibility rule of 9 says means sum of the digits divided by 9. This rule is similar for 3 also. Now I just apply this rule for this sum. I just apply sum of the digits, which is nothing but 5 plus 1 plus y plus 3 by 9. When I add up 9 plus y by 9. Now here we have to find out the value of y. So for this, I just put the values of y according to the options. Okay, for I just take the option A, that is 2 or 3. For y is equal to 2, if I put the value of y is equal to 2, then this become 9 plus 2 by 9, which is equal to 11 by 9, which is not divisible. So it is not a correct option. Here it is not necessary for to check the value of 3, because 2 itself not satisfies. So we next move on to next option, option B, that is 0 or 9. For y is equal to 0, I just put y is equal to 0. 9 plus 0 by 9, which is equal to 9 by 9, which is divisible. So it satisfies the condition. Similarly, we have to check for 9 also, because they given 0 or 9. Here it satisfies the divisibility rule for 0. So now we have to check the divisibility rule for 9 also. Put y is equal to 9. Then 9 plus 9 divided by 9. So 18 by 9, which is also divisible. 9 2s are 18. So which is divisible. So here it satisfies both 0 and 9. So here the correct option is option number B. Question number 5 is, what should be added to 5, 1, 2, 3, 4 to make it divisible by 9? And they given an options as 6, 4, 3, 5. Okay, this is also a previous year question. Previous year, it is a question asked in 2014. Okay, this question says that what number we have to add to this given number so that it must satisfy the divisibility rule of 9. For this, I just apply the divisibility rule of 9 and add the number which are given in options so that it must satisfy the condition. Here the given number is, I just taken the given number as 5, 1, 2, 3, 4, and now I apply the divisibility rule for this number. I apply the divisibility rule of 9. What the divisibility rule of 9 same is sum of the digits divided by 9. So I just apply that rule. 5 plus 1 plus 2 plus 3 plus 4 divided by 9. Now I just cut off the numbers which is divisible by 9. I just cut off directly. That is 5 plus 4 which is equal to 9. So it is cut off. Then remaining is 6. 6 by 9. This is the remaining number. Now I just add up the given option by 1 to satisfy this condition. I just take the option number A, that is 6. Now I just add up this option to this, that is 6 plus 6 divided by 9, which is equal to 12 by 9. This 12 is not divisible from 9, so it is not a correct option. Next I will go through for option B, 4. I just add up 4 to this 6, 6 plus 4 which is equal to 10 by 9. So this is also not divisible. So this is also not correct option. Next, option number 3. I just add up 6 plus 3 by 9. 9 by 9. Yes, it is divisible. It is completely divisible. So by adding 3, the given number completely divisible by 9. So it is the correct option. Here we just apply the divisibility rule of 9. That's all. Question number 6. What least value must be given to y so that the number 91876y2 is divisible by 8, and they given an options as 1, 2, 3, 4. This question is similar to the above one, that is what value we have to add to the given number such that the number must satisfy the divisibility rule of 8. So now the divisibility rule of 8 says that is the divisibility rule of 8 says that last 3 digits must be divisible by 8. This is the rule of divisibility rule of 8. This is the formula you have to remember. Here we have to take the last 3 digits of the given number. So that is, here the last 3 digits are 6y2. Now I will take the last 3 digits, that is 6y2 by 3. I just apply this formula for this number. Now I put the values of y according to the given options and check whether last 3 digits are divisible by 8 or not. Now I just put y is equal to 1 according to the option number A. Then it becomes 612 by 3. Sorry, not 3, it is 8. 8, sorry. The divisibility rule of 8 says that last 3 digits divisible by 8. I just apply this rule for 8 and I taken the value of y is equal to 1. 612 by 8. Now I will just divide it. 8, 612. Okay. Now 8 times 8 into 7. 8 sevens are 56. So the remainder is 5. And I just carry this 2 here. Now 8 6 are 48. The remainder is 4. Here the remainder is 4. So this 8 is not able to completely divide the 612. So it is not a correct option. Next I will go for option B, that is y is equal to 2. 6, 2 to 8. I just replace the value of y by 2. Now I just divide it. 8, 622. Here 8 sevens are 56. The remainder is 6. I just carry out this 2 here. Then 8 sevens are 56. Here the remainder is 6. Here also the 622 is not completely divisible from 8. So this is also wrong option. Next I will go for option 3. That is y is equal to 3. So 632 divided by 8. I want to check this. Here 8 sevens are 56. The remainder is 7. I just carry this 2 here. Then 8 nines are 72. So here it satisfies the divisibility rule of 8 because it completely divides 632. So this is the correct option. Option 3 is the correct option. Question number 7. Which is the following number is exactly divisible by 45? The options are 181560. This is the first option. Option number B 331145. Option number 3 202860. Option D 202350. Okay. Here we have to check the options which are exactly divisible by 45. Here we have to check the options which are exactly divisible by 45. So this 45 can be written as 5 into 9. 5 nines are 45. So if you check the options which are exactly divisible by both 5 and 9, then we will easily get the number which is exactly divisible by 45. Now I will check the divisibility rule of 9 and 5 for all the options. Okay. Now if you observe all the options, all options are completely divisible by 5. All options are completely divisible by 5. Because the divisibility rule of 5 says that we have to consider the last digit. Here the last digit is 0, 0, 5, 0 and 0. Here if you consider the last digit of the given number, that is 0 and 5. This 0 and 5 is completely divisible from 5. So all the options satisfy the divisibility rule of 5. Here remaining is we have to check the divisibility rule for the 9. For this I just take the option number A and I will check this whether this number satisfy the divisibility rule of 9 or not. It already satisfies the divisibility rule of 5. Now I will check for 9. That is what this divisibility rule of 9 says means sum of the digits by divided by 9, that is 1 plus 8 plus 1 plus 5 plus 6 plus 0 divided by 9. Here I am applying the divisibility rule of 9. Now I just cancel out the number which are directly cut off. 9 ones are 8 plus 1 9. So it is also directly cut off. Then the remaining is not divisible. So the remaining is 12 by 9. Here the 12 is not divisible from 9. So it is not a correct option. It satisfies the divisibility rule of 5, but it does not satisfy the divisibility rule of 9. So this option is wrong. Next, option B. This option B satisfies the divisibility rule of 5. Now we have to check the divisibility rule for 9. That is 3 plus 3 plus 1 plus 1 plus 4 plus 5 divided by 9. Here I just add up. Here also it does not divisible by 3 plus 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, here also it is not divisible. Not divisible by 9. So it is also not correct option. I just go through for option C. 202860. This option satisfies the divisibility rule of 5, but we have to check the divisibility rule for 9. So that is 2 plus 0 plus 2 plus 8 plus 6 plus 0 by 9, which is equal to 16 plus 18 by 2, 18 by 9. 9 ones are 9 twos are. Yes, it is divisible. This number already satisfies the divisibility rule of 5. Now it satisfies the divisibility rule of 9. So finally we can say it is the satisfy the divisibility rule of 45. So the correct option is option C, because it satisfies the divisibility rule of both 5 and 9. Question 8 says that what least number must be added to 1056 to get a number exactly divisible by 23. This is also previous year question, but I don't know particular year. This question says that we have to add some number to 1056 such that that number must be divisible by 23. Suppose if I had solution, suppose if I add x number to 1056, it must satisfy the divisibility rule of 23. That is, it must divisible by 23. Okay. Now for this I just divide. That is 23 1056 plus x. Now I will just divide 23 into 4, 92. Here remainder is 13. I just carry this 6 as it is plus 1 plus x. Then 23 into 5. 5 times 115. So here the remainder is 21 plus x, right as it is. Here we cannot proceed further because the remainder, here the remainder is smaller than the divisor. So now I just put the least values of x by looking at these options. Now I just consider the option A, that is 2. Put x is equal to 2. This implies 21 plus 2. 21 plus 2, which is equal to 23. If I put 23, so this 23 is completely divisible by this 23. That is 23 ones are 23. So remainder is 0. So option A is the correct answer. Suppose if I consider option B, that is put x is equal to 3, then I just apply here 21 plus 3, which is equal to 24. This 24 is not divisible from 23, so it is not a correct option. Similarly, if you go through for option C and option D, this is also not satisfied. So here the correct option is option number A, that is 2. Okay. Question number 9. What least number must be subtracted from 13601 to get a number exactly divisible by 87? They given an options. This question is similar to above question, but here we have to subtract some value from 13601 such that after subtracting the remaining number must be divisible by 87. This is the condition what they given. For this I just divide 1360 by 87. 13601 by 87. I just divide it. 87 into 15 times 1305. Here the remaining is 55 and I will just carry this one here. Then 87 into 87 into 6, 522. Here the remaining is 29. This is the remainder. Here we cannot further proceed because this remainder is smaller than this divisor. So now if I subtract this remainder from the given number, that is 13601, I will easily divisible the given number by 87. So the correct option is 29. Question number 10. Sum of all possible values of A for which the 4-digit number 547A is divisible by 3 is they given an options as 7, 15, 10, 13. And this is the 2016 asked question. To solve this problem, I just recall the divisibility rule of 3, that is we already know that sum of the digits by 3. So now I just apply this divisibility rule for this given number, that is solution. I apply the divisibility rule of 3, that is 5 plus 4 plus 7 plus A by 3, because D rule of 3, that is the divisibility rule of 3. Now I will just cut off the numbers which are directly divisible by 3. 5 plus 4, which is equal to 9, so it is cut off. 3 3s are 9, so it is cut off. Then remaining is 7 plus A by 3. Now I just randomly put the values for A such that it must divisible by 3. That is, I just take the random values. A is equal to 1. If I take A is equal to 1, 7 plus 1 by 3, which is equal to 8 by 3. Not divisible by 3, so it is not correct. When I take A is equal to 2, then 7 plus 2. 7 plus 2 by, which is equal to 9 by 3. It is divisible. Then I take A is equal to 3. 7 plus 5 by 3, which is equal to 12 by 3. It is also divisible. Then I take A is equal to 8. That is 15 by 3. It is also divisible. Now they ask to find sum of all possible values of A They ask to find sum of all possible values of A. So I just add up these options which satisfy. I just add up these options, that is which satisfy the divisibility rule of 3. This 3, that is 2 plus 3 plus 8. When I add up this, the sum is 15. This is the correct option, where B. Suppose if they give any other answer greater than 15 in options, then we have to do some more possible values of A, then we have to add up and try to match the options. Okay, here the correct option is 15. Question number 11. If 517 by 324 is divisible by 3, then what is the smallest digit is there in place of y? The given options as 0, 1, 2 and none of these. Here I apply the divisibility rule of 3, that is sum of the digits by 3. I just apply that rule. Sum of the digits means 5 plus 1 plus 7 plus y plus 3 plus 2 plus 4. I just apply the divisibility rule for this given number divided by 3. Now I just directly cut off the numbers which are divisible from 3. 3 is divisible by 3, okay. Then 2 plus 4 which is equal to 6. So 6 is also divisible from 3. Then 5 plus 1 which is equal to 6. 6 also divisible from 3. So this also cut off. Here the remaining is 7 plus y by 3. Now just put options in place of y. That is, I just taken the option as A, that is y is equal to 0, which implies 7 plus 0 by 3. Here it is not divisible. 7 is not divisible from 3. So it is not correct option. Then I go for option B. Y is equal to 1, which is equal to 7 plus 1 by 3. That is 8 by 3. This is also not divisible. So this is also wrong option. Then I will go for option 3. That is y is equal to 2. 7 plus 2 by 3, which is equal to 9 by 3. Yes, it is divisible because 3 3s are 9. So this is the correct option. Option number 3. Next is question number 12. If 481 by 673 is divisible by 9, find y. This also similar to this above question, but here we have to apply the divisibility rule of 9. The divisibility rule of 9 and 3 are similar. So what that divisibility rule of 9 says means sum of the digits by 9. So here I have to take the sum of the digits, that is 4 plus 8 plus 1 plus y plus 6 plus 7 plus 3 by 9. Now I will directly cut off the numbers which are divisible from 9. Suppose here 6 plus 3 which is equal to 9. So it is directly cut off. Then here 8 plus 1 which is equal to 9. It is also directly cut off. Here the remaining is 4 plus 7 plus y by 9, which is equal to 11 plus y by 9. Now I will just put the values of y according to the options. I take option number A, put y is equal to 7, which is equal to 11 plus 7 by 9, which is equal to 18 by 9. It is divisible. It is completely divisible by 9. So it satisfies the divisibility rule of 9. So here the correct option is 7. This all about the divisibility rule problems. If you like my videos, please like and subscribe. Thank you.